Alright, we continue with the use of oil biomarker in exploration. So the third one is it is useful for determinations of thermal maturity of the source rock during generations. And then the last one is to actually assess on the properties of oil, gas, and condensate, mainly on their API gravity and viscosity to assess the level of biodegradation effect or reservoir alteration. So the API gravity here stand for American Petroleum Institute. Okay, moving on. So what are the biomarker? It is actually the molecular fossils or compounds produced by living organisms that found in oil and rock, soil, sediment extract and preserve most of the original carbon skeleton of the original natural product. So here are the examples of biomarker that have been used to evaluate the quality, quantity, age, lithology and depositional environment. Like for example, if you find oleanins in your crude oil, you will ultimately know that your oil is coming from terrestrial or higher plant input or flowering plant derived. And the age of your source rock will be in between late Cretaceous or younger than that. So meanwhile, if you find sterins and hoping, it will indicate that the origin of your oil is from a lacustrine environment. Okay. If you find carbon-20, carbon-25 tricyclic terpenes, it will suggest the origins of shale source oil. And for example, if you find the ratio of phthalates and phytane, okay, with more than 3.0, so it suggests that origin of your oil or your source rock is from coal derived oil. Less than that probably is from hypersaline environment. Less than 0.6, it's your source rock or your oil indicates an anosic environment of deposition. Anosic here stand for the dissolved oxygen in water is less than 0.1 millimeter per liter. Alright, moving on. Okay, the third part of the use of oil biomarker is to estimate the maturity history of the source rock during generations and any interval of oil and gas window. So to do this, you need to divide the petroleum into two groups of hydrocarbon fractionations, which are the first one, saturated hydrocarbon, and the second one is aromatic hydrocarbon. Never mind, you will learn this later on. So this fractionation can be derived or determined using the liquid column chromatography, and later interpret or send for the gas chromatography and gas chromatography mass spectrometry equipment or tools to actually know the fingerprinting of all the alkanes in the crude oil and extracted bitumen from the source rock. And later you will know all those four main things from the oil biomarkers. Okay. However, there are limitations on evaluating the thermal maturity using the oil biomarker, which are first, there will be non-linear relationship between biomarker parameters and source rock maturity. Why? Simple, because the maturation history of the source rock depends on heating rate, source lithophases, and source of organic phases that may change from basin to basin. And then second limitation is the distributions of biomarker actually exist only in a specific maturity interval. Okay, meaning that the fossil molecule has their own temperature limit. Therefore, your interpretation may not precise or not definite. Okay. The third one is the composition and concentration of biomarker decrease with thermal maturity. So meaning here that it is only exists at certain temperature interval. Alright, moving on. The properties of hydrocarbon. Okay, oil biomarker also useful for evaluating the properties of hydrocarbon exists in an entrapment. So what is the properties that we are look for is the viscosity and API gravity of the oil. Okay, so again, the API here is actually or stand for American Petroleum Institute. So the normal API gravity is above 25 to 26. So we need to know the properties of oil itself because the oil might have been altered because of some reasons, and you need this information for drilling purpose later on. So to know the oil properties and accomplish this issue, you will need to actually first collect a group of non-degraded and degraded oil from the same petroleum system, and then you need to make or develop a correlation and transformation between a biomarker maturity parameter and API gravity for both groups. And to do this correction, simple, you need to find the compound that is highly resistant to biodegradation, and you need to evaluate on the differences that you observe, which later can be used to determine the original gravity of degraded oil. Very simple. Alright, part of the task in characterizing the charge wreath is you need to actually use a basin modeling as the third technique to calibrate the 3D modeling and fluid flow modeling. So basically, basin modeling is a process of using commercial software. We call it here Petromod. You will learn this later for 1D basin modeling construction, in which generally is a model of a petroleum system that have a diverse data on geological, geochemical, and engineering input. And the size of model can be one well or the entire of the basin itself. So the resulting model can be used by geologists to first to test on the impact of prospect charge when changing the various assumptions available in the software. So what are the variable here, or the parameter that usually we alter frequently, is the source rock characteristic, head flow, HF, paleo water depth, PWD, and sediment water interface temperature, SWIT. Alright, the second is a model of basin modeling can be used to actually assess the charge wreath with various elements that exist in a given petroleum system. For example, here, to estimate the adequate source rock richness, maturity, and volume, and then we need to actually know the appropriate timing of a generation relative to timing of trap formation. By basin modeling also, we can actually assess on the physical properties of the hydrocarbon charge, and then the possible migration path to prospect by 2D and 3D modeling, and possible post-charge loss by hydrocarbon from the track. Again, 2D and 3D modeling. Okay, third, a basin modeling can be used to estimate the volume generated and losses and the quantity. So for petroleum, like for example, petroleum generated from a given volume of source rock. Second, from a petroleum expelled from the source rock, or even petroleum losses from or during migration, and petroleum delivered and accumulated to the trap. So the model or the basin model available or will be produced will be 1D, 2D, and 3D. And the sophisticated model is actually can be produced depends on the data availability, okay, of the geological and geochemical data, the project goals, and third one is the time and funding available to construct a model. It's not cheap. Alright, next, the technique that an exploration geochemist will be used to character the charge wreath is by using all geochemistry specifically used to determine the origin of light oils and condensate. So the light oils and condensate here refers to the hydrocarbon liquid which at surface condition are high gravity with the API in between 45 to 60 API. Specifically, light oil refers to volatile oil that is liquid at both surface and reservoir condition. okay, with the more percent carbon C and above, more than 12.5. While condensate is a hydrocarbon liquid at surface condition, while it is at a gas state at reservoir condition, which the carbon atom is 5 to carbon 10, and the mole is less than, the mole percent of carbon 7 and above is less than 12.5 mole. So, but with some reason, the such thing that increase of thermal maturity at greater depth and high pressure, you will also find C1 and C18 in gas phase in deep accumulation. So to know whether the high gravity liquid at the surface condition is gas or liquid at reservoir condition, you need to use PVT, pressure, volume, temperature calculation. Alright, the second task of an exploration geochemist is to assess the reservoir alternations. We'll continue this later on. Alteration, okay. We continue. The second task of an exploration geochemist is to assess the reservoir alteration. So, what is reservoir alteration? It is actually a process of alterations of a living organism or microorganism under certain conditions that metabolize various classes of compounds present in oil. And this alteration will actually affect the oil spill, surface seeps, and subsurface oil accumulation, because the condition that lead to the biodegradation is the temperature less than 80 degrees, which usually affect the shallow reservoir. And the process cannot exist at higher temperature because many organisms are not resistant to that temperature. So as a geochemist, your role is you need to target the sweet spot, which is non-degraded oil, within an accumulation that has been affected by biodegradation. Why? Because when biodegradation occurs in an oil reservoir, the process will dramatically affect the field properties, and because each of the compounds found in the oil has their own susceptibility towards the biodegradation process, and later on will affect the value and producibility of an oil accumulation. So the biodegradation will cause in reducing and increasing of this thing. Okay. Fluid properties, value and producibility of an oil accumulation, it will increase on the oil viscosity, so it will reduce oil producibility. Okay. Gravity, it will reduce oil API gravity, so which means that gravity low means density high, thus will create heavy oil, and ultimately we need high cost to convert to light oil. So we prefer to get condensate rather than heavy oil. Next, it will increase aspartame content. Aspartame is solid bitumen in the reservoir oil, which will reduce the permeability of the reservoir rock and eventually will reduce the oil producibility. And last one is it will increase the concentration of certain metals, sulfur and oil acidity, in which oil become more acid and poisonous, and because of high sulfur content, and later will corrode the tubing drilling.